Okay, so let's add a way of showing lives to our player and being able to keep track of them within our game. So before we go and actually create the system for tracking our lives, let's first of all create a way of showing them to the player. So what we're going to do is go into our game object. We're going to create a new UI and a text object on that UI. And much like we did when we were creating our previous project, what we're going to do is take the canvas, and instead of it being screen space, we're going to set it to be world space. And then we're going to shrink it down to be roughly the size of our screen image. I'm going to click and drag that down there like this, and we'll scale it down one more time to be roughly around about the right size, like that there. Perfect. And then we're going to drag our text object here into position. I'm just going to put it there for the moment while we adjust it. And what we're going to do first of all is make sure that that is white, so it's a bit more visible, like that. And much like we did again on the previous project, back on our canvas, what we want to do is set our dynamic pixels per unit to be 2, so that the text will appear a lot sharper over here in the game. And then what we'll move is our text box, and I'm just going to move it into position up here like that. And we're going to change the text that's shown by default to say lives remaining X, just because we don't know what the current amount of lives are. So we'll see in our game view now our lives remaining is just up there in the top, just the way we want, nice and simple. We'll leave the font size at that. I think it's okay there for the moment. We're going to add some more things as we go a bit further forward, but for now that one is fine just there like that. Okay, so now we have our bit of text showing just the way we want to. So let's actually make that manipulable by our game. So we'll go into our game manager here, and what we're going to do is obviously we're going to need a reference to that text object. Because this is using the UI elements of Unity, again we need to go to using Unity Engine.ui. Because as a text object, we're going to create a public text object that we'll call lives text, nice and simple. And the next thing we want to do is create a counter that will actually keep track of how many lives we have. And creating a live system is actually kind of one of the most simple systems that's handy to do in any kind of game, really. So what we'll do is just create a public int that is equal to, or not equal to, we'll call it we'll just call it lives, nice and simple. So we'll say public int lives. So in our start function, the very first thing we'll do as soon as the game starts is say, okay, the lives text that we've used, we want to set the text on that to say lives remaining colon space, and then we put another quotation mark and we'll say plus and whatever our current lives value is. Okay, so we've got our life set up there. So what happens then when we lose a life? So in a respawn ball, at that point, what will happen then is we'll take away 1 life from our lives value. So we'll say, after we set our game actives to be false, we'll say lives minus equals 1, which will take away 1 from however many lives we have. And then we'll say, again, just like we did here, we'll actually just copy the same bit of text, paste it in there, and that'll update our lives counter, or our lives display on the screen, and it'll tell us that tells how many lives we've now been updated to have. So let's we've saved that. We'll pop back in to the game, let that compile for a second, and it's finished compiling. So now we can go to our game manager. We can drag the lives text object into there. We can set our starting lives as 3. I'm actually going to rename this bit of text here to be lives text, just so we know. And now we can play the game, and we should see as soon as it starts up, our lives remaining will change to be 3. There we go. And now if we hit the ball ruling, we lose our lives down to 2. lose another life, down to 0. Now of course we would want to do something when our players' lives gets down to 0, but at the moment all that's happening is our lives will continually keep going down as we go. So the next thing we need to do is set it so that our lives will, as soon as we get to 0 or below 0, that our game will show a little screen to say game over and that we can't go on any further. So when our player runs out of life, we want to send a message to them that lets them know the game is over, you've lost the game, you've no more lives left, basically. So to do that, what we're going to do on our canvas here, we're going to create a new screen that will overlay over our game in the world here. And to do that, we're actually going to create a new canvas, which will be kind of just below the normal one, the world space one. So we're going to create a UI canvas here, and this one we're not going to change that to be world space. We're going to leave this in screen space, so it's nice and big and huge like this. And on this new canvas, we're going to create a new UI image. And this UI image, we're going to change the color of it. Instead of it being just bright white, we're going to set the brightness down to dark and the saturation down to black like that. And we're going to take the alpha value, which is the 4th value here, and drag this down to around about 68. That'll be grand. And then we're going to grab this sprite image that we've created on our canvas, and we're going to drag it out so it's slightly larger than our canvas in the world. And the next thing we want to do is make sure that this gets bigger within our game. So at the moment, if we go in here, we can see now that all our other bits of our screen kind of look a little bit darker. But if we were to maximize this view, so if we go to our game and if we right click on it and then go to maximize, what happens is that bit of image that we created stays the exact same size, and you can see what happens then is that this area is being darkened by that kind of semi-transparent image, but the rest of the area is being perfectly normal and perfectly fine. So that's not really what we want to happen. So what we'll do is when we have the image selected, go over here to where we have middle and center, and so these are the anchor points of the object within the world. So at the moment, by default, it's set to be anchored into the middle of the screen. So what we'll do instead is set it to be stretched out to all 4 corners. So if we click that there and we go back into our game, and now if we right click on this and go to maximize, suddenly our object gets pulled out to cover the whole screen, which is exactly what we wanted to do. So we'll make that back to be a normal size again, go back to our scene view. So now that we have that covering over the screen to make it kind of darker and make it so that our player knows, oh, something's happened, we're going to add a little bit of text on top of this. So we're going to add some UI text. I'm going to make this nice and white so it's nice and readable, and we're just going to make it say game over. Nice and simple. And we'll pop that in the middle there like that and kind of center it a little bit more. Then I'm going to click and drag this out. I'm going to hold Alt while I click and drag to make sure it all gets dragged out evenly. And I'm going to scale up the font size so it's nice and big in the world, just like that. Okay, so the next thing we want to do then, we have this kind of screen in place now. I'm going to set it to be off by default, so we're going to deactivate it there. And we basically need to say, okay, if our game or our lives remaining goes down to below 0, we're going to turn that screen on and we're going to deactivate the ball to make sure that our player can't play anymore. So to do that, we're going to go into our game manager. We're going to need, well, we already have a reference to the ball itself, so we're going to need to have that there, but we're also going to need a reference to the text object that we just created, or sorry, the game over screen, sorry, that we just created. So we're going to create a public game object that we'll call the game over screen. And basically what we want to do then is when we call the respawn function down here, what we're going to do is just after we take away 1 life and before we change the text on the screen to be lives remaining, we're going to add a new if statement here. We're going to say if lives is less than 0, so if we're all out of lives, what we'll do is we will say that we're going to deactivate the ball to start off with because we don't want the ball moving around the screen anymore. So we're going to say the ball dot game object dot set active is false, like that. And then we're going to set the game over screen to be activated. So we're going to say game over screen dot set active is true. Then the final thing we want to do here is to make sure that the lives counter that's on screen no longer says how many lives are left, because if we go below 0, so say if we have then -1 lives, that doesn't look good to have up on the screen. So instead we're going to make it so that lives text will change to say all lives lost. It's just a simple little background thing, and probably most people won't even really notice it, but it's good not to have it throwing up weird random numbers. You don't want to be showing to your player at any point a minus number value, because that doesn't look good at all. So now where we have our lives text being set here to show how many lives we have, we're instead going to wrap this in the else statement. So we're going to say else here, and we're going to add some curly brackets then above and below this bit of lives text. So basically what we're saying is, if the lives go below 0, turn on the game over screen and say all lives are lost. Otherwise, say how many lives we currently have left in the game. So we're going to save that, and we're going to go back into our game here. We're going to need to, of course, hook up our game over screen into our game manager once it finishes compiling. So here we go, we've got the slot for our game over screen. Let's click and drag that into place there. I'm actually just going to rename this image that we have to be game over so that we know that we're talking about the right thing. And then we're going to hit play here, and we're going to let ourselves run out of lives, and we should see our game over screen gets activated and our players can no longer play the game. So we lost 1 life, quickly lose another, and 1 more, and finally we are on our last life. We have no lives remaining. So, boom, all lives have lost, and we got a game over. So perfect. So now we've established how we're punishing our players when they lose the game. Let's now take a look at how to reward the players when they're destroying the bricks by adding a simple score system into the game. Okay, so we're going to add a scoring system into our game to reward our players when they actually destroy the bricks. So unlike previously when we made our lives, where we created our text object to display in the game first, we're going to go and add the code first to our script. So we're going to go into our scripts folder and open our game manager script. It should be open here. And what we're going to do, first of all, we need to create a variable that'll keep track of how much score we currently have. So we're going to say this will be our public int current score, like that. The next thing we want to do is add a function to be able to add score into our game. So we want to be able to, whenever our player picks up or hits against a brick of any kind, what we'll do is make sure that it calls the score and adds it to, or sorry, calls the function that we're about to create, and that will add it on to our current score. So we're going to go down here, and we're going to go below our respawn ball, and we're going to create a function called public void add score, and we'll put our little brackets in. And what we want to do is we want to say, okay, this function that we're creating called add score, that's going to take in a value. So the value it's going to take in will be a new int that we're going to call score to add. So what we're saying is, so say if our ball hits against this object here, that will have a score of 100 applied to it. And what that means then is it'll call the function and it'll pass 100 in. And then here we'll have, okay, we'll have add score, and basically we're saying within this bracket is 100. So then we can say, okay, we can take our current score and say plus equals score to add, like that. And that's pretty much all we want this function to do at the moment. We haven't set up our text on the screen, so we don't need to worry about updating our text just yet. We'll return to doing that in just a little bit. But what we're going to do then is we're going to go back into our folder or into our project here. We have that set up on our script now, and we go to look at our game manager. Once it's finished compiling, there's now a slot there for our current score, and that's perfectly fine. But we need to be able to assign a score value to all our individual bricks within the game. And the way we'll do that is by creating a new game object, create a new C# script, sorry, not a game object. In our scripts, we're creating a new script that we're going to call the brick controller. And we'll open this up in MonoDevelop here. And on this little script, we're going to have the value of whatever our bricks currently are. So that'll be public int brick value, like that. And the next thing we want to do is basically just be able to say, okay, what we want to do is when our brick is destroyed, that it calls from the game manager the add score function and adds the score to it. So to do that, we obviously need to know what the game manager is. So let's create a public game manager, and we'll just call it the GM. And then in our start function, we'll say the GM is equal to find object of type game manager, because we know we wanted to find the game manager as soon as it gets going. And then we need to decide what happens when it gets destroyed. So to control our bricks getting destroyed, at the moment all that happens is when the ball hits against the brick, it uses the on collision exit here and it says, okay, just destroy the other object. We don't care what happens to it. So we're going to change it so that actually what happens when the ball hits against a brick, instead of just destroying it, it's actually going to go to the brick controller and it's going to call a new function on it that we're creating now that we're going to call public void destroy brick, like that. And then on this function, this will call, it'll go to the game manager, so it'll go to the GM and it'll run the add score function, and the score it'll pass in will be whatever brick value we give it. So we'll say brick value, like that. Make sure we put our semicolon at the end. And then the next thing we want to do, as soon as it's sent the value out to the game manager, the next thing it'll do is just destroy itself. So it'll just go destroy game object. Nice and simple. So now that we've set that up, we need to go to our ball controller script. And here, where we have it set to destroy, we're just going to comment that out by putting two little slashes in front of it, because we're no longer using that code, but you don't really want to delete old code in case it becomes useful again at some point in the future. And instead of that, we're going to say, okay, on the other game object, we want to get the component that's attached to that, which is the brick controller component. And on that brick controller component, we want to say dot destroy brick, which is the function we just created on it. So basically what this does is it'll go to the other game object the ball just hit against, and then it'll get the component, which is the brick controller, and it'll destroy that brick with that function. So we can save that now, and that's all the little basic bits of code we need to add in. So we can go back into the game and we can apply that script to our bricks. So once it finishes compiling again, we will let that happen, and we'll go to our first original brick. We'll add the brick controller script to it, and we'll set the brick value to be 100. I just realized the game manager has been set as public and there's no real need for that, so we'll set that as private. There's no reason why you can't set all your variables as public. All it really does though is end up with you ending up with a fully clogged up inspector over on the right, and you can end up adjusting values that you don't want to adjust. So it's always kind of sensible to try and keep things logically. If you don't need to be making a change to a variable, just set it as private so you don't need to think about it. Okay, so we've added that to our first brick, so let's hit apply, so that'll be applied to all the prefabs. So now all of our bricks along this line here have different I have the brick controller script attached to them, but we can make changes to them. So say for example this orange one, we can set the value of him to be 500. We could set this pink one here to be worth 1,000 points. As long as we don't hit the apply button, these point values only apply to the specific bricks that we've created here. So what we can do now is hit play, and actually I should have the game manager highlighted. So if we have game manager highlighted, we can see that our current score at the moment is 0. But now if we press play, every time we hit an object, our score gets added on. So you can see as we bounce off our different objects within the world, we get it all adding up as we go. Okay, so we've got the functionality of our score manager in place. So now let's make it be displayed to the player. So we've created our score system, so let's show it to the player and how they can actually keep track of what they're doing in the game. So the first thing we're going to do is take our lives remaining that we had here. We're going to go into our canvas and we have our lives text. I'm going to duplicate this. I do want to point something out, just in case anyone's having any issues with our canvas kind of making it so that you can't click on other objects in the game. Sometimes Unity can do this, sometimes it won't. But if, for example, we put our canvas over everything that our player can see, and now you can't click on any of these objects in the world, that's because the canvas is in the way. And the way we can change that is if we go to our canvas down here, you'll see that it's set by default to be on the UI layer. So what we can do is go up to layers up here, and where we have UI, we'll have a little lock symbol beside it. We can unlock it like that, which will make it so that we can click on the layer. So now what I've done is I can't click on any of these bricks anymore unless I'm already on the active canvas layer. So if I'm not clicked on anything, if I go to click on one of these bricks, instead it'll select the whole canvas, and then if I go to click on a brick, then it will activate to it. So if you've been having the issue where you're having to click on an object twice to activate it in the game, what you can do then is go to our layers drop down here and turn that lock on. And basically what that means is you can't click on that object in the world to activate it. So at the moment I can't click on either of these UI canvases, and I can't click on the bit of text here to activate it. But it means it makes it much easier to click on absolutely everything else within your game, which is more than likely some of the things that you're going to want to interact with more. So to activate then our little bit of lives text that we just copied, we need to click on it in the hierarchy, and I'm going to rename this to be the score text. Then I'm going to click and drag it over to the right here, like roughly like so. I'm going to align the text to be on the right there like that, and then I'm going to change the text in the box here to say score XXXXXXX, just to demonstrate how our score could be. And we'll actually, just in case our players manage to rack up some kind of crazy mad score in the game, we're going to make sure that this text box can stretch out quite a bit. So we're going to select the little kind of anchor tool, and we're going to click and drag that over to the side just so we can go out quite far within our world. There's no real chance that they're going to create a score that's like that long, but we just like to have our bases covered when we're working on these things in the game. Okay, so we've got our score text object created, so let's create a reference to that back in our game manager and display the current score to the player at all times. So we're going to go to our game manager, we're going to create that reference, we're going to say public text score text like that, and then in our start function the first thing we're going to do is say, okay, our score text is equal to score with a space plus whatever our current score is, like that. And then the only other thing we want to do then is down in our add score function, we want to go, okay, score text, we could just have copied the same bit of text, but we'll just type it for easiness sake. So score text.text is equal to score space plus score text. So perfect, there we go. We can save that, we'll pop back into our game, and we'll make sure we hook that new value up that we just set as the score. Once we go to game manager, oh, we've got a bit of an error here. 27 said it was on line 27. Oh, we should have said this was score text dot text. That was why, because we're accessing the text element of the score text component. So we'll save that again. Okay. Oh no, I hit play there. I really shouldn't have, because we haven't set up what our score text actually is. So we'll undo that and we'll go to our game manager and click and drag our score text into the correct slot, and then we can hit play. And now every time our player gets a bit of score by hitting against one of the bricks. Why is it's showing up the wrong thing there? Did I? Oh, I set it to be score text down here. That was the problem. We want to set that to be current score. We don't want to say score plus the score text, because then it's just going to tell us the name of the object in the game, which obviously is no use to us at all, really. We'll hit play. And we start moving, and we see our score gets updated as our player scores points. So perfect. We've got a nice little simple point system added into our game. Now, one problem with how our scores are being added to the game at the moment is when our players are playing the game, it's kind of hard to see actually how much points you're getting for anything at any particular time. So if we fire our ball off, if you look up at the score counter in the top right, you can see how much score you're getting, but it's kind of hard to keep track of that when you're in the middle of a game. If we have a whole screen full of bricks, it's not very easy to be able to keep track of where our what our score is and what we're getting for any individual brick. So we're going to add a little effect that will make a little object be created when a brick is destroyed that will show how much that brick was worth, and it'll just kind of slowly count down and then disappear, basically. So to do that, we're going to create a new script, create a new C# script that we'll call we'll just call it score effect, and we're going to open this up then in MonoDevelop. Give that a second to get working. There we go. So what we're going to do, we're going to want to set a value to say what the current score is that we just got from the brick being destroyed. So we're going to have a value to use for that. We're going to use public int score value, and then we're going to have another value that we use to track how much time is left for this object to survive. So basically it's going to just count down and count down and count down, and then as soon as we run out of time, it'll destroy the object. So we're going to create a public float called lifetime. So that's just going to keep track of how long this object stays alive for, and then it'll destroy it from the game. So we're going to save that just like that. So the final thing we're going to want to do is, this is going to be an object with just text on it, because all we want to do is make it display to the player what it is. So if we know that if we're going to be using text to display something, we're going to need to use the Unity engine .ui. So here we can just say public text, we'll just say score text like that. So what we're going to want to do, we're going to have an update loop here. Basically we're just going to have this constantly counting down and saying until it goes below 0, and then it'll destroy the object. So what we can do is say our lifetime is equal to, is it minus equal to, so to make sure that we're counting down, what we're going to use is the time.deltaTime value. Now we've encountered our time.deltaTime in the previous project, and as we said then, our time.deltaTime is basically how long it takes between one frame update of the game and the next. So if we're running at 60 frames a second, our time.deltaTime will be 1/60th of a second. So if we want to make it count down in real seconds, so say our lifetime is 5, we make it subtract whatever the time.deltaTime is, so that every frame is counting down and getting closer to 0, and it'll count down in real time so that we end up at 0 when our lifetime should. So what we'll do then, if our lifetime is counting down, we can say if lifetime is less than 0, so if it goes below 0, then just destroy the game object. Nope, not with a capital G, because that will destroy the concept of game object. No, we want to destroy the particular object that this script is attached to. Okay, so we've created that script, so let's create the object within our world now. And then we'll create a way for the bricks, as they're being destroyed, to access that object. Okay, so we're going to collapse all these items that are here. Like that. And then I'm going to create a new canvas. So we're going to go to UI and create a canvas like this. Again, we're going to make this a world space canvas. And we're going to shrink it down within our world, nice and small. And I'll move this down here into position here. We're actually going to make it quite small on our screen, so it's just this tiny little object down here. Then we're going to create a bit of UI text on it. At the moment that text is very, very small, so I'm just going to first of all change it so that it's a nice white color. Then I'm just going to zoom in a bit and make this quite a lot bigger like this, and make the font size quite a lot bigger too, and I center that in the middle there. I'm just going to make this say, for now I'm just going to make it say 100. So if we drag this just into, oh no, we want to drag the whole canvas just into roughly the right position here. And if we switch to the game view, we can see this is roughly the same size as a brick, and that's what we want it to be about the same size as one of these bricks here. It doesn't need to be precise or anything like that, but we just want to have it in the general kind of area. And I'm going to rename this object to be, or the canvas object to be the score effect, like that. And I'm going to apply the script we just created to it. So we're going to drop that and drop it in there. Score value we're not going to set, because this will be set when a brick is destroyed. Lifetime, we're going to set the lifetime to this to be about 2 seconds should be enough time to be able to see the score and for it to register and then be able to disappear. And we want to set the score text value down here. We want to click and drag our text object, which is a child, and put it in a position there like that. Okay, so we've got our score effect object. Now we're going to make this a prefab. And the reason we do that is so that our bricks will be able to create this as an object in the world. So bricks are able to copy any object that already exists, but they're also able to create objects that are prefabs. Now I said bricks there are able to do it. I meant any object within the world, not specific to these bricks here, but any object is able to instantiate, is what it's called, an object into the world. So now that we've made that a prefab, I'm going to actually delete it from our scene. So we've deleted that prefab, but we still have our score effect object in the prefabs folder. So the next thing we're going to do is make it so that our brick controller can create a copy of that object and apply the score that's attached to the brick controller to it. So we'll go back into our folder here, and we're going to go to our brick controller here. And basically, whenever we destroy a brick, we're going to create a copy of that score effect. So first of all, we're going to need a reference to the score effect object. So we'll create a public game object that we'll call score effect, like that. And then down here in our destroy brick function, to make a copy of that object in the world, basically what we say is instantiate the object that we want it to instantiate. So that'll be our score effect object, score effect. We hit a comma, and then we have to say where we want our score effect object to appear. And of course, where we want it to appear is where our brick currently is. So we can just say transform dot position. And then finally, we need to say what rotation it should have when it appears in the world, because it needs to have a rotation for us to be able to use it. And we'll just use the same rotation that the bricks have, which will be 0 anyway. So transform dot rotation, like that. Okay, so that's perfectly fine. We're now able to instantiate that object within our world. But of course, we'll save this now and we'll pop back into our game. We'll demonstrate this in action, but this won't actually give us the correct values for any of our objects. But we can see it in action first before we do anything else. So what's important to note now is, unlike in the previous project where we discussed, if you, for example, on our bricks here, if you create a reference to a game object if you create it within the scene itself, then you won't be able to apply that to the prefab. So if we were to drag one of these objects into here, then it would stay as bold no matter what we do. But because we're creating a reference to another prefab, if we drag our score effect into the score effect slot, and then we go back up and we hit apply, this will actually carry over and apply to all the other bricks as well. Because this score effect is another prefab, so it knows where to find that. It knows it's not just in the scene that we have here. It's stored in our assets, and it's able to be used within our game. So now if we hit play, once we get it going, we can hit our spacebar and we can see we get our 100 being created, and after a couple of seconds they get destroyed. So perfect, they're doing exactly what we want. The only problem is they're not actually showing the correct score. So to make them show the correct score, what we need to do is say that we're not just instantiating this object and not doing anything else with it. We want to be able to apply certain things to it. So what we'll do is say that this score effect that we just created is actually a game object that we're going to call, we'll just call it the score object. So we're saying we're creating a new game object that's called a score object, and we're setting that to be equal to the object that we just created. Now, the way instantiate works within Unity is you're actually instantiating an object, not just a game object. We want specifically a game object here. So what we actually have to say is that this thing we were creating here, if we put in a bracket before it, if we put game object, just like that, what that's doing is telling Unity that this thing we're about to instantiate is a game object. So we're able to set it as a game object called score object. So now that we have that set, we can go on to the next line and say, on the score object that we just created, we want to get the component called score effect, like that. Actually, that should be a capital S. So we want to get the component of score effect, and on the score effect we want to change the value, the score value, to be equal to what our brick value is. So we want to say score value is equal to brick value. And then we also want to say on our score object, we'll get the component of score effect, and we want to, this time, if we switch over to our score effect, we want to go to our score text here, which is our public score text, which is displaying how much score we have, and we want to go in there and go into our score text and go into the text element of it and set that to be equal to our value that we just sent in, which is the score, the brick value. So we could also set this to be equal to whatever the score value is stored as here. So what we've done here now is we've created kind of two steps to doing this. We've adjusted the score value on the score effect, and then we've also adjusted the text. But just in typing that, I don't really know what I was thinking, but there's no real reason for us to apply the score value because the object will just be destroyed. So I'm just going to delete that line from the script like that, and then back in our score effect I'm going to delete that reference here, the public int score value, because we don't need to worry about that. We can just save that and delete it. So we can save this here. So now that we have our brick value being set as what's being displayed by the score text, we can go back into the game here, let that compile. Oh, we're getting an error. Oh, we can't convert it into a string, of course. So the reason it's coming up as an error here is because our brick value is an int. If we're going to send some text to our score text, we need that to look like a string. So it needs to look like a collection of characters or whatever. And the way we convert this into being a string is to just say, we just put our two quotation marks at the start, and then we add on the brick value. So we've seen before when we've added strings to make text show up. So say for example, if we go to our game manager, we've got, say, lives remaining here, plus lives, and we've got these little quotation marks at the start of it so that it knows that it's a string, and then we're saying what the lives are. So here we need to say, okay, this is a string, but there's nothing within it, and then afterwards we're going to say whatever the value of the brick is. So we can save that and pop back into the game, let it compile down again, and as soon as that's done, what we should get when we play the game and let our bricks or let our ball hit the bricks, there we go, we get the correct score being shown on the screen. So we can see those ones are worth a little bit more. I can't remember what any of these ones are worth. I put up another one as having a value, didn't I? I don't know what it was though. One of these guys, there we go, that one's worth 500. So there you go, you can see it's now shown the correct scores to our player, and you have enough time then to realize what's going on and which scores are being applied to the player. So now that we've got the basic fundamental gameplay of our game in operation here, we're going to add some of the fundamentals of how the game can actually be managed, some of the almost administration of the game. And we're going to start out by creating the main menu. We created the main menu in the previous game that we made, but we're going to do something a little bit different on this one. So we're going to start off by making a new scene first of all. So we're going to create a new scene. Similar to what we've done before, we're going to change the background color to be a nice dark black to keep everything nice and consistent. And this time, instead of adding text to say the name of the game, we're going to add an image to show the name of the game in a little bit more of an interesting way than just a blank kind of standard bit of text. Okay, so to do that, we're first of all going to go to Game Object up here and then UI, and we're going to add an image like this. And we need to zoom out nice and far so that we can actually see our full canvas size here. Then I'm going to click and drag this image here. And we're going to change where we have a source image here. We have an empty slot on the image because it just creates it as this default white image. But what we're going to use is in our art folder, one of the files we dragged in was this little Brickbusters logo. So I'm going to pop that in there. And you'll see when we drag it in first on the UI, it just fills into the square shape that we created before, or that was created by default, shall we say, by Unity. And we obviously don't want that. So what we'll do is click this little button for preserve aspect, and it'll make it fit down in the right side or the right shape that it was originally brought into, but it'll fit itself into the box that's been created. But obviously that's a little bit too small still, so we're going to click and drag this and stretch it out so that it looks a little bit bigger on our screen. And then I'm going to center it into position here like this, and we're going to leave it so that it's anchored in the middle like it has been before. So we've got our big logo. I'll actually move it down a little bit and we'll make it even a bit bigger again. There we go, that looks fine. Now you'll notice that if we zoom in on it, it's kind of a little bit blurry looking. That's not really what we want in our game. This is a kind of a classic old school looking game, and this kind of blurry logo doesn't look so good. We want it to look more like solid pixels. So to fix that, we're going to go to the original art file. We're going to scroll down, and where it says filter mode here for bilinear, we're going to change that to be 0, and we're going to change the compression to be none, because we don't want this to be compressed at all. And we're going to change the max size as well while we're here. And like I said before, what we want to do is set the max size to be the minimum number above the longest edge of our thing. So the longest edge of this is 160. So we need to go and look here. So the next number above 160 on our list here is 256. So we'll go for that one and we'll hit apply, and we'll see our image gets automatically changed. So now it's a sharp image for us. Absolutely perfectly what we wanted to do. So perfect, we've got our little logo in place now. So let's go ahead and make the buttons that we're going to use. So we're going to go to our game object and add a new UI button. And this button, we're going to change the text on it to say start game. Nice and simple. And then we're going to duplicate this and click and drag it down here. And I'm going to have this bit of text say quit game. And those are going to be our only two options, because we don't have a single player and multiplayer as we did in the previous game. We're only going to use these two buttons like this. I'm going to drag this down a little bit lower. And we're not going to overcomplicate it by adding in any extra other things at all. So we've got our start game and our quick game. Obviously we don't have them actually doing anything at the moment, so we need to give them a script that will allow them to actually have some functionality, much like we did in our previous project. So we're going to go ahead and create a new C# script and create main menu script. We'll let that compile and open up in MonoDevelop here. Should take a second, or maybe it won't open for me. Nope, there we go, we've got it. Okay, so much like we did before, we'll need a string to tell us what the name of the level is that we're going to load. So the level we're going to load up will be public string first level, and we're going to have two functions then. And instead of start and update that we're not going to use at all, we're going to use a public void that we'll call new game, and we'll do a public void that we'll call quick game with a small a. So we'll write our quit game function first. We'll just say application dot quit. That's all we have to do, and that's how we can make our users be able to quit out of the game. And then up here we're going to include our scene management so that we're able to load levels within Unity. So using Unity engine dot scene management, and then in our new game function here we're just going to say scene manager dot load scene first level. Perfect. We'll save that, and I will pop back in to Unity here. Let that compile for a second. And once that's done, we can go to our canvas. We're going to add the main menu script to that again. Oh, I spelled first level wrong, I just realized. That's not very helpful. So let's just go and check what is the name of our first level. We have it set as level 1. Oh, it's trying to use this originally spelled bad version there. We go back in here. So we have it spelled as level 1 here. So that means on our main menu script that is attached to our canvas, we want to make sure this is spelled as level 1. Perfect. So let's then grab our two buttons. We're going to add one function to both of the buttons, drag our canvas into the slot, and then set the function for each one to be the correct one. So for our start game, we want it to go to our main menu and then go to new game. And then on our quick game, we want it to go to main menu, quit game. Perfect, nice and straightforward. Now that we have all that set up, let's make sure we actually save our scene. So we're going to file, save scene as. We'll save this as the main menu scene. And now, in order to be able to test this out, as we had to do before in the previous project, we need to make sure that Unity knows where to find these levels that we want to load. So we need to make sure and add them in to the build settings. So we have our scenes and build. At the moment there's nothing in there, so let's drag our main menu in first, and then we can put our level 1 in. And as we said before, the reason we put main menu first is so that this will be the first thing that gets loaded up by Unity when the game starts. Okay, so now we need to make sure we can test it. So let's hit the play button, wait for it to get going, and now we hit the start game and it'll load us into our first little level, so we can play away to our heart's content. Perfect. But what if we're in the middle of playing our game, having our bits of fun, and we get distracted by something and we have to stop for a second? Well, at the moment we can't really do anything. We can't pause the game. We have to just try and either finish this level or just let ourselves die. So let's fix that up, and we're going to add a pause menu into our project. So I've switched back into our main level, and we're going to add a pause menu into the game so that when our players are in the middle of playing the game, they can get interrupted and they don't have to worry about running away or anything like that. So I'm going to scroll out so we can see our big canvas on the screen. And then down here where we have our game over object and bit of text, if I activate that here, we can see our game over and our little bit of text. I'm actually going to duplicate this object. So we're going to duplicate our game over, and I'm going to rename this to be pause for our pause menu. We're going to activate this here as well. And now instead of it saying game over, we obviously don't want that. We're going to change the text to say game paused with an exclamation mark. Actually, that's kind of just fits in just there perfectly, so I'm going to move this up here a little bit. And also on this pause menu, we're going to add some buttons so that our players can actually do some things while they're playing the game. So we're going to go back up to our main layer, and we're going to right click on this and go to UI button, and I'm going to change the text on this button to say resume. And I don't want to move that down, I want to move the whole button down, so we'll move the button down to there. Then I'm going to duplicate our button and say that this one will say quit to main, and then we can click and drag this one down, and we'll duplicate it one more time, click and drag it down, and then we'll change the text to say quit to desktop. Okay, so perfect, we've got our game pause screen all working here. So the first thing we're going to do is set up so that these buttons will actually do something. So we're going to need to create a pause menu script to do this. So we're going to go down to our scripts folder, and we're going to right click and create a new C# script that we will call pause screen. Wait for this to compile and open up here in MonoDevelop. Give it a second. Oh, there we go, it's flashing orange at me. So our pause screen is going to have a couple of different functions in it. I'm not going to delete our start and our update just yet, because we're going to want to make use of them in a little while. But for the first thing we want to do is look at our three buttons that we have. So we have a public void resume game, and that'll be for letting our player get back into playing the game. We'll have a public void quit to main. Oh, we don't want that space in there. Quit to main, and that'll take us back out to the main menu. And then down here we have a public void quit to desktop. So on our quit to desktop, obviously we're going to have this again be application.quit, like that. On our quit to main, we're going to need to load up the main menu, so we're going to need to again include the scene management elements of our Unity engine. So Unity engine dot scene management, like that. So now that we've included that, we can go to our quit to main, and we'll obviously need to know the name of our main menu as well. So we're going to create a reference to it up here. Actually, we don't need to create a reference, because much like we did in our previous project, we know that our main menu is always going to remain the same. So we can just hard code that in here, so that whenever our players are quitting out of the main menu, they're always going to the same thing. So we can just type in here scene manager dot load scene main menu, and we need to make sure that's exactly how we spelled main menu back here in the game. So we go to our scenes folder, we've spelled it the exact same, and we've capitalized it the exact same. So that's all we want to do in our quit to main. And then finally we have our resume game. But to know how we're going to resume the game, we need to know how we're going to actually activate this pause screen. So you can imagine that when we're playing our game, we want our players to just be able to press a button, which will pause the game, and then it'll activate this screen. So when we want to go back into the game, we want the game to, or we want our players to be either able to press the resume button here, or again be able to press a button on their keyboard, and it'll go back into the game and deactivate this screen. So the only thing we know for sure is that we want to deactivate that screen. So here we know that if we press the resume game button, we wanted to grab the game object that this script is attached to and say set active false. So how are we going to be able to pause the game and bring this screen up? Well, the best way to do it will be to use our game manager. So our game manager is always constantly running, we know that. So what we can do is say, okay, on the game manager, wait and see if the player has pressed the button, and if the player presses the button that should activate our screen, then activate the pause menu. So let's do that first of all. So we're going to need a reference to the pause menu, of course. We're going to use public game object, just pause screen, like that. And then in our update loop here, we're going to wait for the player to press the escape button. So the escape button will be, it's a generally used button for pausing a game on computers in general. So we're going to say if input.getKey down keycode.escape. Now there's one other button that we also want to use. So if someone wants to pause the game, there's two things that they will generally try and press first of all before they try anything else. Those will be escape and obviously pressing the P button, because P for pause. So we're going to add the ability for our players to press pause, but previously when we've used if statements, up here we've said, okay, if our player is pressing space and the game is not active, then we're able to check something. And to do that, we use these ampersand symbols for and. But what we want to do is say if the player presses escape or if the player presses P. So rather than having two completely different if statements, what we can do is just add in two little bars like that, which when you're coding in C# here, these two bars represent or. So much like these two ampersands represent and, these two bars represent or. So then we can say input the got key down key code escape or input dot get key down key code dot P. Perfect. So that's what we want our if statement to be. So now we're just checking to see if the player presses escape or if the player presses P. And if either of those things happen, then we say, okay, what we want to do is set our pause screen dot set active is true. So that'll activate our pause screen. But what if we want our players, or if our players have already paused the game and want to deactivate the screen? Well, in that situation, we'd obviously want to be setting our pause screen to be false. So instead of just setting our pause screen to be active like this, we're going to add an extra if statement above it, and we're going to say, okay, if our pause screen that should have a small p. If our pause screen dot active self, so active self is a way of checking if an object is currently active within Unity. So what we're saying is if our pause screen is currently active, then what we want to do instead of activating the screen, we want to say pause screen dot set active false, like that. So then we're saying, okay, deactivate the pause screen if it's already active. Otherwise, so else, otherwise we want to set our pause screen to be active. So we want to set it to be true so that it activates. So let's go ahead and test this out now back in our game. So we have our pause screen all set up and we just need to hook it up in our game manager to do all this stuff. I should actually attach the pause script to our pause button here and hook up the buttons too, while we're connecting things at the time being. So we'll go to our pause object in our game hierarchy and we're going to add the pause screen script to it. Then on these individual buttons, we're going to create a new action on them when we click them, and we're going to click and drag our pause into that slot. And then on each individual button, we're going to give them the right function. So pause screen will have resume first of all, then we'll go again for pause screen quit to main, then pause screen quit to desktop. Okay, so we've got those set up. Now let's go to our game manager. We now have our empty slot for our pause screen, so I'm going to click and drag that in here, and now we're going to hit play to play the game, and we'll see our pause screen will be activated by default. But at the moment I'm also able to move the character around within the world, which isn't very good. So we're going to take a look at that in a second, but let's first of all test out that our pausing and unpausing is working. So I'm going to hit escape, and there we go, our screen disappears. Hit it a few times, it turns on and off and on and off. We can hit P and it does the exact same thing, and we can also hit the resume button to get rid of the pause menu. So that's all perfectly fine, but what about when we pause the game and now I'm able to use my little paddle to move around the world, and I'm also able to fire the ball. So the ball can keep firing and we can keep playing the game. That's not very good. That's not what we want to happen at all. So how do we make the game actually stop moving when the screen is activated? I'm going to disable the screen because we don't want it to be coming up as soon as we start playing the game. We want it to be deactivated by default. But we'll go back into our scripts, and what we're going to use is a thing called time.timescale, and the time.timescale controls what speed the game is currently running at. So basically what we do is here where we want to set our this line here where we're setting our pause screen to be active and we're wanting to pause the game, what we say is time.timescale equals 0. And what that'll do is it'll say, okay, we want to change the timescale that the game is currently running at to be 0. So by default in Unity, our time is running at 1, which means for every 1 second in the real world, 1 second on the computer passes by. If we set our timescale to be 0, what that means is for every 1 second in the real world, 0 seconds in the game will pass by. So it won't make anything move forward at all. But we're still able to do stuff within the game like manage pause menus and things like that. So if we're setting our timescale to be 0 when we pause it, we then want to set it to be time.timescale equals 1 when we unpause the game. And we put a little f afterwards because we need to make sure that our timescale is actually using a float number. And whenever we want to use a float number and there's some ambiguity because the computer won't magically know necessarily that a 1 isn't an int. We want to explicitly say that it's a float, so we put a little f after it. So that's why we're saying time.timescale equals 1f, and what that means is it'll go back to running in perfectly normal time. So if we're doing that when we unpause the game in our game manager, we need to do the same thing back in our pause screen. So here in our pause screen, when we resume the game, we're going to say time.timescale equals 1f. So that'll make sure the game goes back to being playing when we're actually go back from pausing the game. Okay, so let's test this out in the game itself. We'll start it rolling here while it compiles in the corner. And we'll start playing. We'll set the ball firing, and if I pause it, now you can see that our ball is frozen in place, and our score effect that shows the score value of the brick that we just destroyed is no longer being destroyed after 2 seconds. So the length of time that it stays there is being paused while we pause the game. And that's why we use time.timescale, because it freezes absolutely everything in the world in place. So now if we resume the game, you can see everything goes back into running. It continues counting down to 2 seconds to every object being destroyed. And we can see there that the button pressing worked for unpausing the game. So let's do the same with just pressing the button on the keyboard. It does the exact same thing. It makes us be able to control whether the game is moving or stuck in time. So perfect. That's working absolutely wonderfully for us. But there is one more little issue that's being caused. And that is, so we're playing our game, we pause, we get interrupted and do something else. And we go, okay, I've only got 1 life remaining. I might as well just start over again. So I go to quit to the main menu. I go to start the game. And now I start trying to play. And everything's frozen. It doesn't work. I try to move, nothing happens. I try to launch my ball, nothing happens. And I'm like, oh no, my game is broken. I don't know what's happening. What's happened is that when we paused our game, we set the timescale to be 0. And then we loaded into a completely different scene. But when we load into a completely different scene, it still retains whatever timescale you set Unity to be working at. So the only way to fix this is to make sure that when we go do something else coming out of our... Actually, I just stopped this running. When we go do something else coming out of our pause menu, when we quit to main or we quit to desktop, we want to make sure that we set our timescale to be back to 1f. And just to be absolutely sure that we don't accidentally do this somewhere else and cause some other errors, we also want to go to our game manager, and we'll go into our start function here in the game manager, and we're going to say, okay, set our timescale there to be 1f. So we know that no matter what happens, as soon as we start the game, we want our timescale to run at the speed that it should run at. So with our players now able to pause the game whenever they want, and also able to go back to their main menu and play through the main menu into the first level of the game, we now want to create some progression so that if our players go into a second level, or if they complete the first level, they're able to go into the second level of the game. So to do that, first thing we're going to do is create a copy of our first level, just to use to be able to load into the next one. So I'm just going to save this level first of all. Then I'm just going to go save scene as, go into our scenes folder, and we're just going to call level 2. And I'm just going to make a simple little change to it just to be able to stand out so that we can tell that we're in level 2 and not level 1. And just to do that, I'm just going to grab this green brick and move it down. Obviously, for as you make more levels in the game, you probably want to mix it up and make different patterns with the bricks and stuff like that. That's the kind of standard way that you would do in this kind of brick breaker type game. But we're just going to make it stand out to make it nice and simple for the purposes of our tutorial here. So we moved it down. I'm going to save this level, and then we're going to switch back into our level 1 that we're using as our main level template. So we've got that in place now. Let's scroll back out and go back out to our canvas, and we're going to take our game over screen again, and we're going to duplicate it, and I'm going to activate it obviously, and we're going to change the name of this to be level complete, like that. And then we're going to rename this bit of text, or not rename it, but change what it says to say level complete. I'm going to adjust the size of it so it's a little bit bigger too. There we go. Then we're going to create another little bit of text below it that will say, just change the color of it first of all. This bit of text will say, press any key to continue. And we're going to adjust the size of this to make it a little bit easier to see for everybody. Hold down Alt to make sure we adjust it evenly. And then I'm just going to center it and make the font a little bit bigger too. There we go. Perfect. So we've got our level complete, and we've got press any key to continue. So now let's make some code to make this actually happen. So the first thing we're going to do is make the code that happens when this screen is activated, and then we'll set up in our game manager how to activate this screen. So we're going to go into our scripts folder and create a new C# script that we're going to call level win screen, and we'll open this up in MonoDevelop. And this is going to be a very simple script. Basically, all it's going to have is, we're going to have a reference to the name of the level that we want to load up next. So that'll be public string, we'll call it next level. Next level. There we go. And then in our update, we're just going to check and see if the player presses any button. So as soon as this screen is activated, we can just wait and see if the player presses anything, and if they do, then we'll tell it to automatically load up. And the way we check for any button being pressed down, we just say if input dot any key down. So as soon as any key is pressed, what we want it to do is load up using our scene manager. So again, to use our scene manager, we need to add using Unity Engine dot scene management, and then we can say scene manager dot load scene, and the scene we want to load is whatever we set to be next level. So perfect, nice and simple and straightforward. So we'll save that, go back into the game here, let that compile for a second, and once it's done, we'll add that script to our level complete here. Pop it in there. So the next level we're going to want to load from level 1 will of course be level 2. And to test this out, we're just going to run the game, let it go for a second, and we'll see our level complete is activated because we just left it active. And I'm just going to hit a random button. It'll take a second. Oh wait, no, it didn't work for a second there. Oh, we never set I never set level 2 into our scene manager, of course. So I need to go over to we need to stop this running, go back into our build settings and make sure that we add our level 2 scene into the build settings, and now we can press play again. And once it stops, or once it starts going even, now we press a button and there we go, we've loaded into level 2. You can see by the extra little brick that we moved down, and now we can just go ahead and play the game. So perfect, our level complete screen is working, but now we need to add a way into our game manager of activating this screen. So with our level complete screen now working just the way we want to, we need to set it up so that it gets activated when all our bricks are destroyed. So I'm just going to, first of all, I'm just going to deactivate it because we don't want it to be open as soon as our game starts. And we're going to scroll in here, and what we're going to do is set it up so that our game manager is constantly checking to see if there's any bricks in the level. And if it finds out that there's no bricks left, it's going to say, okay, there's no bricks left, turn on the level complete screen. So to do that, what we're going to do is, first of all, we need to go to our game manager script, of course. We're going to add in a reference to the level win screen that we just created. So we're going to say a public game object level, we'll just call it level win. And then we're going to scroll down into our update loop. And then at the end of our update loop, we're just basically going to say, we're going to create a new variable that we're going to call our brick checker. So we're going to say var for variable, and we're going to call it brick check. And the reason we use var is just because it's a generic variable, and it's not something that we're going to want to reuse too much. We're just going to use this kind of generic variable, and we're going to set that to be equal to an object that we're going to search for. So we're going to say find object of type brick controller, because we know that all the bricks that exist in the level have the brick controller script attached to it. And so what we're going to do is search for any object in the world that has a brick controller script, and we'll assign that to this variable. And then we can say if this variable, our brick check, is equal to null. And what that means is if our brick check is empty. So if our brick check is empty, then we know that we've done the find object of type brick controller, and it hasn't been able to find any brick controllers to assign to this. So that means our brick check must be empty. So if our brick check is empty, then we know there's no more bricks left in the level, so we've won the game, or we've won the level at least. So then we can say our level win dot set active is true, so we're activating the level win screen. And we also want to make sure that we're pausing our time scale. So we want to say time.timescale equals 0, because we don't want our ball to be flying around the screen still after we have won the level, because it could end up with the ball going down into the pit and our players losing a life. So we want to make sure that we pause time when we win the level, and that was also why we set it in our game manager here, why we set our timescale to be 1 as soon as the level starts. Because if we're going to pause our game when we win the level, we want to make sure when we start a new level that our timescale goes back to being what it should be. Something I didn't discuss previously, but of course you could set your timescale to be at half speed if you wanted to make things a little more interesting for your players, or even double speed and to make things more harder. But for now we'll just stick with our timescale being at 1. Okay, so we've set that up now, so let's go back into our game and test it out to make sure it actually works. So first of all, once it compiles, we need to go to our game manager and connect our level complete screen over to our empty slot that will appear in a second. There we go, there's our empty slot. Let's pop that in there. I'm going to delete these 6 bricks here for the moment. I'll undo it in a second. But for now, I'm going to leave just these 2 here, because as we've been playing the game, every time we've launched our ball, it's destroyed these 2 bricks first of all. So to test out, we know that I'm about to destroy these 2 bricks, and that should, there we go, it activates our level complete screen. And now if I press any button, we've loaded up into level 2. So perfect, it's working just the way we want it to. Now of course we haven't, this level 2 here is actually an old version of our level 2. We haven't set up a level complete screen on this one at all. So if we manage to destroy all the bricks on this level, which I'm not doing so good at, but if we do, we won't actually have any level complete screen in this screen at all. Let's see if I can get the, nope, didn't do so well there either. Let's see if I can bounce it over this way. There we go. So you can see now we were getting an error because the game manager doesn't know where to find the level complete screen on this level at all. So we'll need to probably delete that level 2 scene. It was only used as a practice, and create a completely new one if you want to. But for now we're perfectly fine where we are. So we can see now our level complete is working just the way we want it to. the next thing we want to do is when we move from one level to the other, at the moment, for example here, if I was to just let the ball go up here and bounce down and lose a life, and then try and get both of these things here. But there we can see at the moment I have 1 life remaining and I have a score of 1100. When I go into the next level, my lives are set back up to 3 and my score is set back to 0, because those were the default values we gave, and at the moment we're not carrying any of that stuff through our levels. So let's look at a way to add carrying our score and our health in between levels.